All right, so we are going to start our unit on matrices. Okay, matrix is one, matrices plural. Okay, matrix, matrices. Okay, I understand that this graphic originated when I was in high school, but does anybody get the reference I'm trying to make? Yeah, one, two, three. Okay, a few people. Okay, they made a movie called The Matrix. Came out when I was in high school, which I now realize has been a really long time. Okay, but let's talk about what a math matrix is. Okay, not the movie with all the weird stuff that happens. Okay, a matrix, which you talked a little. I mean, what, like 3 days in algebra 2? You talked about matrices. Okay, you only did a couple things with them. But a matrix is a rectangular array of numbers. It looks sort of like numbers organized in a table format where we have rows and columns. Okay. I have an example of a matrix right here for you. So they use kind of like bracket notation. Okay, that's how we know it's a matrix. And we don't have any like lines, we don't have any commas, but you can see how there are rows and columns, and that's how we organize our numbers. Okay. Each number in the matrix is called an entry. So when we describe these are our different entries. Okay, there are 6 entries in this matrix. We also describe the order of the matrix. Okay, so matrices can be of various sizes. So when we talk about what we can do with matrices, a lot of time their size is going to be important. What is it? Friday we're going to talk about adding, subtracting, multiplying matrices. So their size is going to be an important part of what we do there. So we need to describe their size. So we are going to describe the order of a matrix. And the order we're going to say is the number of rows by the number of columns. Okay, so first we're going to pick out the number of rows, then we're going to pick out the number of columns. Okay, so how many rows does this matrix have right here? There are 3 rows, and how many columns? 2. So we call this a 3 by 2 matrix. That's its order. Okay. Maybe you can help me fill in this last blank right here. A blank matrix has the same number of rows and columns. Oh, I like that. But it's actually what? Somebody said over here. Square, yeah. I like the word perfect. I do. But we're going to call it a square matrix. Okay? Because it, in that rectangular array, it's now a square. Okay, so when I say a square matrix, it means we have the same number of rows and columns. Okay, so down below this, I have 4 matrices that you, as a group, I want you to determine the order of each of these. Okay, take about a minute or so, and as a group, determine the order of these 4. All right. Katie, what's the order of A?
1 by 1.
There is 1 row and 1 column. That's the most boring matrix ever, right? Okay. How about B? Tenchi, what order would we have here? Good. We have 1 row and 4 columns. C. Brecken, what is the order here?
2 by 2.
Okay. So this is a square matrix. So this is a square matrix because we have the same number of rows as columns. We also say that this is a 0 matrix. Why would I call this a 0 matrix?
All the entries are 0.
All of the entries are 0, okay? So this is a 2 by 2 0 matrix, okay? And then the order of D. Reagan, what would that be?
3 by 2.
We have 3 rows and 2 columns, okay? Yes, part of your homework will be just determining the order of a matrix, okay? Those problems should go pretty quick for you, okay? Now, we can't really escape our linear equation part of chapter 7, okay? So we are going to move into matrices, but we're also going to take a little bit of chapter 7 with us, okay? This is something that you would not have talked about last year in Algebra 2, okay? But an augmented matrix is a matrix that can be derived from a system of linear equations, okay? Which is what I have below for you right here, okay? Matrices, and we're going to do a lot of different things with matrices. The first being what we call an augmented matrix and doing some things with it. But matrices can be very, very helpful in solving systems of equations, especially when we get more than 3 variables, okay? Now we're going to really focus more on the 3 variable stuff, but we can get into 3, 4, 5, 6, 7 variables if we want to, okay? But what we're going to do for an augmented matrix is we are going to take the numbers that appear in our equations and put them in our matrix, okay? But we're going to not write the variable. So my first row would look like this. 1, -4, 3, there's going to be like this series of dots, 5. And that represents the equation 1x minus 4y plus 3z equals 5. Okay. Our next row would be -1, 3, -1, our series of dots, and then -3. And that represents the equation -1x plus 3y minus 1z equals -3. Now what about our last row? I'm going to write 2 and then what? 0 because there's not a y, and then -4, series of dots, 6. So you can see in our augmented matrix we have a column for all of our x coefficients, and a column for all of our y coefficients, a column for all of our z coefficients. Where we normally see the equal sign, we have these dots kind of separating that out, and then our constants are in a column by themselves, okay? Between today and tomorrow, I'm going to show you what we can do with this matrix in order to be able to solve it. But for right now, we need to understand how to get from one form to another and what can we do with a matrix. Okay, so the first thing I'm going to have you do is take this matrix and work together at your pod to write it, take this system and write it as a augmented matrix. Okay, first I want to know the order of the matrix. Sophie, what would the order of our augmented matrix be? 3 by 4. Okay, we have 3 rows and 4 columns. Okay, Caden, read off the first row to me.
1, -2, 3, those little dot things, and then 9.
Good. Okay, our second row, Eli.
-1, 3, 0, -4.
Very good. And our last row, Ryan.
2,
Do you see how all of my rows are in line? All of my columns are in line. Everything needs to be nice and organized. So be very careful when you do this. It'll be nice when you have your lined paper, and some of you will take a line for each row. Okay, but just make sure your columns, you're not getting too close to each other so you can tell which entry is in which column. Okay. All right, well, once we have an augmented matrix, what are we allowed to do with it? Okay. At the bottom of that first page, you see what we have. We have what we call elementary row operations. There are 3 things that we can do with our rows within a matrix. So it is allowed to interchange 2 rows. I just ask that you actually let me know what you're doing so I can follow your work. So we can take row 1 and switch it with row 2 to where our new matrix is the matrix 4, 5, 6, then 1, 2, 3. But do you see how I notated that? Row 1 switches with row 2 and I have the arrows to notate it. I need to be able to follow your row operations. Okay. Okay. If we think to a system of equations, are we allowed to take 2 equations and write one first and the other one second, and then maybe flip-flop how we write them? Does that really matter? No, it doesn't. Okay. The next elementary row operation we're allowed to do is multiply a row by a non-zero constant. Okay, don't multiply by 0. That's not going to do anything for you. But we can multiply by a non-zero. So I could take row 1 and multiply it by -4. And so then my new matrix would be -4, -8, excuse me, yep, -12, 4, 5, 6. If we're thinking of an equation, have you ever multiplied an equation by a number on both sides? We do it all the time, right? Especially in chapter 7, okay? And we'll keep talking about how this compares to our systems of equations, okay? It's also possible to add a multiple of a row to another row. Did you ever multiply an equation by a number and then add the 2 together? That's exactly what we did for elimination, right? Okay, so it's okay to do that within a matrix, okay? So what I'm going to do with this right here, I'm going to take -4 times row 1 and add it to row 2, and it's going to become my new row 2, okay? So we're going to take -4 times row 1, add it to row 2, and that's becoming our new row 2, all right? So I'm going to keep row 1 the same, okay? But I'm going to take -4 times row 1 and add it to row 2. So I'm taking -4 times 1 plus 4. -4 times 2 plus 5. -4 times 3 plus 6. Now I promise you there is a purpose for us doing these, and you'll see more about, we'll do a lot more of these tomorrow with an end goal in mind, but today we just kind of got to figure out what we can do, what it means, what it looks like, okay? But these elementary row operations, okay, if we change a matrix 1 time, 2 times, multiple times with these row operations, all of the matrices that we change from one to the next we say that they are row equivalent, okay? So even though we started with 1, 2, 3, 4, 5, 6, and we changed it to something else, the matrix looks different, but they're still row equivalent, okay? It's okay to do those things, okay? So we're going to go through an example here that looks more like what you're going to see in your book, where they're going to give you tonight in your homework maybe 2, 3, 4 row operations to do from one matrix to the next. And then with that matrix, do another one. And with that matrix, do another one. Okay? So do you see how I have instructions for us and I've given us a matrix? Okay? So our first one, switch rows 2 and 3. Okay? So we're going to take row 2 and we're going to switch it with row 3. Okay, so row 1 gets to stay the same. I'm writing too big. Hold on. Row 1 gets to stay the same. And then row 2 and 3 get to switch. Okay, so here is now my row equivalent matrix. We have taken care of switch rows 1, 2, and 3. Okay, now it is asking us to add row 1 to row 3. Let me please explain what that means. Row 1 gets to stay the same, row 2 gets to stay the same, but we're going to add row 1 and row 3 together, and that's going to be our new row 3. So we're taking row 1 and we're adding it to row 3, but since we're adding it to row 3, that is going to replace row 3. Okay, so rows 1 and 2, go ahead and copy down from our new matrix, okay? So 2, 0, negative 4, 6 is our new row 2, okay? So from our adjusted matrix, we're going to take row 1 and add it to row 3. So we have 1 and negative 1 to add together for a new entry. And negative 4 and 3 to add together for a new entry. And 3 and negative 1 to add together. 5 and negative 3 to add together. Okay. How do we feel about that? Not that bad, right? Follow instructions. Okay. Tomorrow we get to decide what we're going to do. All right. But in today's homework, they're just going to tell you to do this row operation, then do this row operation, and then do this operation. Okay. Now, we have these row operations. But why? What are we going to do with them? Okay. So there's 2 forms that I have highlighted in that box, right? They're called row echelon form. And when you come up with new math things, you get to name them. I don't know why the echelon. I'm sure it's somebody's name, but row echelon form. Okay? So there's 2 types. First, there's just row echelon form. And this is how we do it. Any row of all zeros goes to the very bottom of the matrix. Any row of all zeros goes to the bottom. In all of the other rows, their first non-zero entry is 1. Okay. So all of the other rows start with either 1 or 0 then a 1 or 0, 0 then a 1, but its first non-zero entry is 1. And for 2 successive non-zero rows, the leading 1 in the higher row is further to the left than the lower row. Thank you. Okay, so what the heck does that mean? Okay. If we have an augmented matrix, okay, your row is either going to start with 1, start with 0, then a 1. Okay, notice how in all of these rows, my first non-zero entry is a 1. After that, there's really, it doesn't matter. Okay. But what happens for 2 non-zero rows, so for 2 rows in a row, I don't like that, but the 1 in the top, in the row above is further to the left. So notice how we go from top to bottom, the 1s just kind of go 1 to the left each time, and it creates like this seat belt of 1s. And what is underneath all of the 1s? Zeros. Okay, so this is row echelon form. Reduced row echelon form. Reduced row echelon form. Zeros are above and below every leading 1. What does that look like? This is an augmented matrix in reduced row echelon form. So we have this, I like to call this the seat belt of 1s. I don't know, it looks like a seat belt, right? There's like that diagonal of 1s. Below all of the 1s are zeros. Above all of the 1s are zeros. Okay, so why? Why do we have these 2 forms? What possibly could be helpful about these 2 forms? Okay, so if we were to translate this to a systems of equations, what does this equation say? X equals 5. What does this equation say? Y equals 3. What does this equation say? Okay, so from this, we can tell that the solution is 5, 3, 2. That's pretty cool, right? Okay. If we can get our matrix with our row operations into reduced row echelon form, bam, we know what the solution is. Now, sometimes that could take some work. So what if we got it into reduced row echelon form? Okay? Excuse me, just row echelon form. So here is another example of row echelon form. Let's look at how this can be helpful. Obviously, reduced row echelon form is super helpful. But what about just this row echelon form? Let's go ahead and translate this. What does this first row mean? This first row means x minus y plus 2z equals 4. This row means y minus z equals 2. What does this last row mean? Z equals negative 2. This isn't going to be so bad, is it? We know z is negative 2. Then what can we do?
We can solve for y.
We can come back here and solve for y. Y minus negative 2 equals 2. What's y? Y is 0. Then what can we do?
We put those 2 in to solve for it.
Now we can come way up here. And we know x minus y plus 2z equals 4. So what's x?
0.
I think it'd be 8, right?
Oh,
Because
yeah.
this would be negative. Okay. So our solution is 8, 0, negative 2. Okay. So we can get, and this is what we're going to do tomorrow. I'm going to give you an augmented matrix, and we are going to do row operation after row operation after row operation. And if we can get it into this form right here, man, we can, without a whole lot of work, get our x, y, and z. Okay? What do you think? Okay. All right, let me go ahead and stop this. So your homework is on your gold sheet. Really, tonight's assignment is pretty nice, ladies and gentlemen. It is